everyone, and welcome. Let's dive right into this explainer on concave mirror ray diagrams. If you've ever struggled to memorize exactly where an image forms when you're looking into a curved mirror, you are absolutely in the right place. Today, I'm going to share a foolproof trick that lets you draw any ray diagram without any rote memorization whatsoever. Just pure, simple logic. Let's get to it. So here's our roadmap. 1. The basics of concave mirrors. 2. The 4 rules of images. 3. What happens when the object is far away. 4. When it's near. And finally, putting the whole picture together. I promise you, by breaking this down logically, mastering all 6 cases is going to be an absolute breeze. All right, Section 1. Basics of concave mirrors. The absolute most fundamental concept to grasp here is that an image depends entirely on where your object stands relative to the mirror. And based on that spot, we get one of 2 results, real or virtual. Now, when light rays bounce off the mirror and physically intersect outside, right in front of it, they create a real image. But if they only appear to meet inside or behind the mirror, well, that's a virtual image. So just remember, physical intersection outside equals real. Keep that in your back pocket. Moving on to Section 2, the 4 rules of images. Think of these 4 behaviors of light as your ultimate cheat code. Step 1, we always need exactly 2 light rays originating from the exact same point on our object. Step 2, a ray passing through the center, that's point C, reflects straight back on that exact same path. Step 3, a ray traveling parallel to the principal axis reflects straight through the focus. And step 4 is just the reverse of that. A ray passing through the focus reflects parallel to the axis. Honestly, just applying these rules will elegantly solve literally every upcoming scenario. Section 3, when the object is far. Let's start with case 1, object placed at infinity. We're going to begin our spatial journey by placing our person incredibly far away from the mirror. I want you to imagine what happens to light rays when they travel from an infinite distance toward our concave mirror. Because the object is infinitely far away, all the light rays arrive perfectly parallel to the principal axis. And what did our 3rd rule just tell us? Parallel rays reflect through the focus. So all these rays bounce off the mirror and converge perfectly at the focus point. Since the rays physically intersect outside the mirror at a single dot, we get a tiny, point-sized, real image right at the focus. Makes sense, right? Let's step in for case 2, object placed behind center, C. We're walking our person a bit closer now, placing them a defined distance just behind the center point. We fire 2 rays from the top of the person's head. Ray 1 travels parallel and reflects through the focus. Ray 2 goes through the center and bounces right back. See where they cross? They intersect neatly right between C and the focus. But here's the really fascinating part. Because the rays originating from the top of the person's head intersect downwards, below the central axis, our real image is actually inverted. It is totally upside down. And if you look at the size, it's actually slightly smaller than our original object. Now for case 3, object placed at center, C. We're stepping our object perfectly onto the center point. This is actually a very special milestone in our journey toward the mirror. We apply our trusty rules to draw 2 rays again, one parallel reflecting through the focus and one through the focus reflecting parallel. And wow, they intersect exactly under point C. This brilliantly illustrates a key fact. When you stand exactly at the center of curvature, your image forms right there at the exact same spot. It's real, it's inverted, and remarkably, it's exactly the same size as the original object. Section 4, when the object is lower. We are now officially crossing the halfway threshold and moving into the inner space of the mirror. Case 4 places our object between the center, C, and the focus, F. We're getting pretty close now. We cast our 2 rays using the rules and check out this brilliant shift in the pattern. The rays now intersect way back behind center C, so our image is actually forming further away from the mirror, and look at the size. For the very first time in our journey, the image has grown larger than the original object. It's still real and inverted, sure, but now it is significantly magnified. Which brings us to case 5. We've reached a critical tipping point here, placing the object directly on the focus, F. When we fire our rays from an object right at the focus, our rules dictate that they reflect perfectly parallel to each other. And because they're perfectly parallel, they will technically never cross in front of us. They are going to meet all the way out at infinity. This creates an absolutely massive, real image that is infinitely far away. So, here's a question for you to ponder. If standing at the focus pushes the image all the way out to infinity, What on earth happens when the object takes one more step and physically crosses the focus? I mean, where can the image possibly go if it's already infinitely far away? Well, let's find out in case 6 between focus and mirror. This is our final rule-breaking location. I gotta say, this is my favorite scenario because it brilliantly illustrates how crossing the focus completely shatters the previous pattern. When the object is this intimately close to the mirror, the reflected rays don't converge. They actually diverge, spreading wide apart outside the mirror. Since they literally can't meet outside, our brains trace them backward, and they intersect inside the mirror. This forces the image to form behind the glass, giving us our one and only virtual, completely upright, and highly enlarged image. It's a real game changer. Finally, section 5, the whole picture together. Just look at the beautiful, logical pattern here. As the object moves closer to the mirror, from infinity down to C, down to F, the image does the exact opposite. It starts tiny at the focus, moves further away, and steadily grows larger. And the moment we cross the focus, bam, it dramatically snaps into that virtual, upright state behind the mirror. You really don't need to memorize a table. You just need to understand this elegant dance between the object and the image. Notice how the image changes with position? You see, physics isn't about memorizing random facts from a textbook. It's entirely about recognizing these underlying logical patterns. Once you know those 4 basic rules of reflection, the universe practically does the rest of the work for you. But it does leave us with one final fascinating question. If a concave mirror, which curves inward, can create this wild, shifting dance of real and virtual images, what on earth happens to the light when you turn the mirror around and it curves outward? We'll leave you to ponder that one. Thanks for joining this explainer, and keep looking for those patterns.